Hello, my dear boys. Hope all of you are well by the grace of Almighty. Today we are discussing chapter 6. The name of this chapter is Effects of Heat on Matter. And today's our topic is creative question solution on this chapter. So let's calculate how to calculate or how to solution of a creative question on this chapter. So, my dear boys, the stream of today's CQ question is the distance between two electric poles is 30 meter. A copper wire with a length of 30.01 meter was connected to those two pillars on a day when temperature was 30 degree Celsius. The coefficient of linear expansion of copper is 1.67 into 10 to the power minus 6 per Kelvin. The wire snapped in a winter day when the temperature of the air is 4 degree Celsius. Okay. Now the question is the question is a define triple point temperature. B. If two bodies have equal amount of heat, if two bodies have equal amount of heat two bodies have equal amount of heat, can they be at different temperature? Can be can they be at different temperature? Explain. And question C is express the temperature of air of the air in Fahrenheit scale. And the question number D is explain the cause for the wire to snap with mathematical logic. Explain the cause for the wire to snap with mathematical logic. Okay, so the question number A is define triple point temperature. So we know that triple point is a temperature that at particular temperature and pressure the water remains stay in three state such as solid, liquid and vapors. Okay, and the question number B is, if two bodies have equal amount of heat, can they be at different temperature? Yes, they can be at different temperature because the amount of heat does not depends on the body. It depends on the heat capacity of a particle, or for a same particle for a same body for a same particle for a same particle, the amount of heat relates on its size. Okay, if the size of a body is big, then the heat of this body will be greater than the small body. Okay. Okay. Then our question number says, express the temperature of the air in Fahrenheit scale. And question number D is, explain the cause for the wire to snap with mathematical logic. Now we will calculate the question number C and the question number D. Okay. Now the solution for question number C is, here given that the temperature in Celsius scale is the temperature of the temperature of air C. Here the temperature is given in Celsius scale, so we denote it as C. So C is 30 degrees Celsius. We need to convert it in Fahrenheit scale. So F equal to what? We know the relation between Celsius and Fahrenheit scale is C by 5 equal to F minus 32 divided by 9. So by cross multiplicating we can write F minus 32 equal to 9C divided by 5. So we can write F equal to 9C by 5 plus 32. So putting the value of C, 9 into 30 divided by 5 plus 32, we will get our, by calculating we will get our final answer, and the final answer is 86 degree Fahrenheit. So the temperature of air in Fahrenheit scale is 86 degree Fahrenheit. We can write, so the temperature on Fahrenheit scale is 86 degree Fahrenheit. This is our solution for question number C. Now we will calculate the question number D. Okay. Okay. For question number D, here we have given that we know that when temperature is decreased, we know that when temperature is decreased, the copper were contracted and tore. Okay, the copper wire contracted and tore when the temperature is decreased. So we need to determine the value of decreasing at temperature 4 degree. Then we can discuss about the method for snapping of the copper wires. Okay, for this math, for this question number D, we have given that the initial length of the copper wire length L equal to 30.01 meter. Temperature here for this question D, we have two temperature. One is the 30 degrees temperature and other temperature is for winter is 4 degree Celsius. So temperature theta 1 equal to 30 degrees Celsius and theta 2 equal to 4 degree Celsius. So we can write del theta, or the difference of these two temperature is 32 minus 4 degrees Celsius or 26 degrees Celsius, or we can write 26 Kelvin, because we know that the difference of temperature is equal for Celsius scale and for Kelvin scale. Okay, so we have given that alpha, the linear coefficient of copper is 16 point 16.7 into 10 to the power minus 6 per Kelvin. Okay, now first of all we will calculate the increasing or the decreasing value of the length. Okay, we know that alpha, we know the alpha equal to del L divided by L 1, we can denote the initial length as L1 into del theta. So del L equal to alpha L1 del theta. So we can write 16.7 into 10 to the power minus 6 into 30.01 into 26. So by calculating we can get the answer 0.01303 meter. We know that for decreasing of temperature the copper wire will contract it. So this is the contract value. This is the contract value. So for winter the length will be, the initial length will be the length of the wire because of contraction equal to 30.01 minus 0.01303. Okay, the final answer is 29.997 meter. So we can say that the distance from pole to pole is 30 meter, but for winter, after contraction, the length of the copper wire become 29.997 meter. So this is the length from the distance between the two poles. Because of this contraction, the copper wire will snap. Okay, I think all of you are clear. Try to do another solving another CQ question on this chapter. Okay, so in our next class we will also try to solve another CQ question. So until then, thank you boys.